Today we're going to talk about rendering haptic effects. Now, in the previous lecture, we gave an overview of how haptic rendering works, and let me just briefly review it now. The idea is that you have a human operator who is holding on to the end effector or the haptic interaction point of a haptic device. That device measures the operator input, and that movement of the stylus is getting translated into a virtual environment. And this is what we're talking about today, the virtual environment that you will program, and what are the equations that you'll use to describe that virtual environment. And the output of those equations is going to be the force, which is the desired haptic display output, which eventually gets felt by the user. So let's get into some examples of haptic virtual environments that you can program. Probably the most basic building block of all haptic virtual environments is the virtual spring. Now, this equation here will look very similar to Hooke's law, which you've seen probably in a high school physics class, which really just says that the force a user feels is proportional to their movement, that is, to their position. And the constant of proportionality is this value k here. So let's briefly review these different variables again. F is the force to be felt by the user, and we're going to call that F throughout the lecture. K is the stiffness of the virtual wall that you program. If K is 0, the person feels nothing no matter how they move, because F will always be 0. If K is large, then the user is going to feel a larger force based on their movement. X is going to be the position of the haptic interaction point, or you can just think of it as the position of the user as represented in the virtual environment. So we could say that this position of the user here is what we'll call X. So the user's grabbing onto something and moving it back and forth. If we say that this is X equals 0 here at the wall, and the user moves all the way to this point here, then the user is going to feel a force, this load force, which equals F, pulling back on them, trying to bring them back to the 0 position. And we're going to define it such that X equals 0 at this 0 position at the equilibrium point of the spring. Now let me talk a little bit about this sign here, because getting the signs right in haptic virtual environments is very important. The negative sign here indicates that the force is going to actually be in the opposite direction of the user's movement. So you can see this drawn here. If the user pulls on the spring in this direction, we're going to assume that real objects always have positive stiffness. So this load force has to be pushing back in the opposite direction. And that's why we have the negative sign here. So that the larger the distance the person moves over here, the larger the force will be pushing back on them in the other direction. And this equation still works if the person starts moving this way, because now this spring will start being stretched in the opposite direction. And now the person's moving in the negative x direction, and you wind up with a positive force, again bringing the person back to an equilibrium. So let's look at how this would look for your hap kit. So on your hap kit, here's your main sector pulley. And the user is grabbing onto this with their fingers, like this, and they'll be moving it back and forth. And let's say that this is the positive x direction. And so x is the arc length along which the user travels as the system rotates about this point. And remember that you have a motor down here, which is going to provide the actuation force. So if the user wants to feel a virtual spring, what they would do is, if this is your original point, you want the user to be feeling a virtual spring. And so now the user has moved the hap kit to this new position. There's our motor. So it's been rotated and it's moved some distance x, and we want to display as if there's a virtual spring k there. There's going to have to be a force which is pulling back on the user to that 0 position. And you can swing this hap kit back and forth, and you'll feel a spring on both sides that are always trying to pull you back towards vertical.